All right, number 6. It says Anthony is approaching a north-south bridge. I'm going to pause. I'm going to draw this. We have a bridge that's north and south. So this will be our bridge. The black line will represent that. Let me add on. So north would be up, south would be down. Okay, that was 300 feet long across a river. So this is 300 feet long. And we have some river that's going across it this way. So we have some river here and here. That'll represent the river. So all this is our river here. From his current location at the end of the bridge on the other side, from his current location, wherever he is, the end of the bridge on the other side of the river, so let's just say he's somewhere over here, then this for the bridge across this side of the river is located on a bearing of north 27 east. Okay, so we have a direction. So for a moment, I'm just going to say, here's this person A here for Anthony. And he looks across and it says on a north 27 east. So from his location, let's just put him right there at the arrow. He would have his own northeast southwest system that he's looking at. Here's his north. This would be his east, south. West would obviously be this way. If this river continued on past him like that, he's going to look and find out that the river is north 20, the point across the bridge is north 27 east. So this would need to be 27 degrees. So north 27 east. That's what Anthony determines that this length is, north 27 degrees east. It says the front of the bridge, okay, that would be here. That's the back of the bridge. This is the front of the bridge. On his side of the river is located on a bearing of east north 7. Oh, okay, so he's not even level with it. So Anthony's actually a little bit lower because it says east 7 north. So from the east, we need to add in a whole new, let's go here. Here's his northeast southwest. Let me bring this down now. Oops, not that one. That one will change. But let me draw like this. And so here's Anthony's northeast. I don't have south on there, but Anthony's right there. So this would need to be like that. So that's the 27 degrees to get to that point. And now we're saying it's east 7 degrees north to get to the front of the bridge. So east 7 north, kind of like that. So this would be 7 degrees here. Right there, that's 7 degrees. Oops, I wrote 70. 7 degrees. So we want to find out how far is Anthony from the bridge. It looks like we're looking for this distance there. That is what we're going to be searching for. Okay, so here's what I know. From north to east, that's a total of 90 degrees. And it looks like I have 27 over here and 7 on the outside. So these 3 angles together should be complementary. That means complementary that if you took 90 and you subtracted the 27 and you subtracted the 7, you should find out how many degrees are right in there. And so the angle I'm going to get, complementary means adds a 90. When I subtract this, those two together are 34. So 90 minus 34 is 56 degrees. 56 would go right there. That's where 56 would go. Okay, so that's a 56 degree angle. And now I notice I have a completed set because this is 300 feet. So I have a completed set. Notice I have the angle and the side across from it. So I'm looking for this distance here. So to find this distance, I need to know, if I want to use law of sines, I need to know that angle up here. So I'd have a complete, that would be the set of itself. So I know I'm going to have law of sines. The law of sines, let me come over here. Law of sines. The law of sines right here. I know I'm going to be using this formula. That's the formula we'll be using on this one. So I'll go ahead and copy this in. Let me shrink it down quite a bit. So that's the formula we'll be using. So I'm going to say that sine of my set here is 56 degrees over the 300 will equal, now I need to find this angle, which I don't have it yet. But if I come over here, I do notice I have 2 angles, 2 lines that are parallel. They're both going north-south. Let me add a south on this one. And I notice this is called a transversal, a line that connects them. So what I can do is this: however many degrees are on this side of the line will be congruent with the amount of degrees on this side of the transversal because they're alternate interior angles. So what I'm trying to say is this. Let me use a different color I haven't used yet. That this angle right here is congruent because of alternate interior angles to this angle right there. So what is this angle? Well, this looks like it's 90 plus 7. That angle right there would be 90 from the south to the east plus this 7 more. So it'd be 90 plus 7, which is obviously 97. So that angle right here will be 97. Now, if that's 97, now I can find this one because every triangle has a total of 180 degrees. And I am working with a triangle here. If you hadn't figured that out, the 2 red lines plus this one gives me a triangle. So it appears to me that I would take 180 and subtract my 2 angles. I would subtract my 97, and then I would subtract my 56. So go with my calculator. 180 minus 97 minus 56. It gives me 27 degrees. So 27 degrees is the angle that's going to go in right here. That's 27 degrees. Move that down. Okay. And so now I can solve the rest of this. I can say sine of 27. Whoops. Sine of 27 over x. And we'll just insolve that to get our value. Or you could cross multiply and divide. But I'll just go ahead and insolve this. So menu 3, 1. It'll be the sine of 56 degrees over. Let me put the degree symbol just to be safe. Even though it says degree, just to be safe, that degree symbol is found in the pi button, equals sine of 27 over our x. And again, if you want to solve this by algebra, you just cross multiply and divide. You multiply across and then divide to get x isolated. Let me add the degree symbol there as well. Degrees. And yes, the answer would be 164.283. So I want to say approximately 164 point, I'm going to round to the nearest 10th, 3 feet is how far Anthony is from the bridge. Now I have a DOL for you to try. Try to draw a picture and see if you can solve based off this information given here.